Welcome to our channel. Please like and subscribe. What is quantum physics? Explained in the simplest way possible. Imagine this. You're sitting in your room, looking at your phone, feeling completely certain that everything around you is solid, real, predictable. Now imagine this. At the smallest level of reality, nothing behaves the way you think it does. Objects can exist in two places at once. Particles can disappear and reappear somewhere else. And simply observing something can change what it is. This isn't science fiction. This is quantum physics. And in the next few minutes, you're going to understand it in the simplest way possible. No complicated equations, no confusing jargon, just clear ideas that will completely change how you see reality. Let's begin. Everything you experience, your body, your phone, the air around you, is made of atoms. And atoms are incredibly small, so small that if you lined up 1,000,000 of them, they'd barely be the width of a human hair. But atoms aren't the end of the story. Inside atoms, there are even smaller pieces, electrons, protons, neutrons, and inside those, even smaller particles. This is where things start to get strange. Because when scientists looked closer, they realized something shocking. These particles don't behave like normal objects. They don't follow the rules of everyday life. Instead, they follow an entirely different set of rules. The rules of quantum physics. In your everyday life, things are either one thing or another. Ball is a ball. A wave is a wave. Simple, but in the quantum world, particles can be both at the same time. An electron, for example, can behave like a tiny particle, a point in space, but it can also behave like a wave spread out across space. This is called wave-particle duality, and it means that at a fundamental level, reality isn't as it seems. It's more like a cloud of possibilities, not a fixed object. Let's make this real. There's a famous experiment called the double-slit experiment. Here's how it works. Scientists fire tiny particles, like electrons, at a barrier with two small openings. If electrons were normal particles, they would go through one slit or the other. Simple? But that's not what happens. Instead, they create a pattern on the wall behind wave pattern, as if each electron went through both slits at the same time. But here's where it gets even stranger. When scientists try to observe which slit the electron goes through, the pattern changes. Suddenly, it behaves like a normal particle. It chooses one slit, not both. In other words, the act of observing changes reality. Just by looking, you affect what happens. This leads us to a key idea in quantum physics: superposition. It means that a particle can exist in multiple states at the same time. Not one or the other, but both, until it is observed. A simple way to think about this is like a coin spinning in the air. While it's spinning, it's not just heads or tails, it's both. Only when it lands does it become one. Quantum particles behave similarly. They exist in all possible states until something measures them. Then they collapse into one outcome. Now here's something even more mind-blowing: quantum entanglement. When two particles become entangled, they are connected, no matter how far apart they are. You could take one particle and move it across the universe, and the moment you change one, the other changes instantly, faster than the speed of light. Einstein called this spooky action at a distance, because it didn't make sense. And honestly, it still feels strange today. But experiments have confirmed it. This is real. Reality at the quantum level is deeply connected. In everyday life, we expect certainty. If you throw a ball, you can predict where it will land. But in quantum physics, you can't predict exact outcomes, only probabilities. You can say, there's a 70% chance the particle will be here, but not exactly where. This means that at the deepest level, the universe is not deterministic. It's probabilistic, built on chances, not certainties. So why does any of this matter? Because quantum physics isn't just theory. It powers the world around you. Your smartphone uses quantum principles in its electronics. Lasers used in medicine and technology are based on quantum behavior. Even modern computers depend on these ideas, and now scientists are building quantum computers, machines that could solve problems far beyond what we can do today. All of this comes from understanding how reality works at its smallest level. Here's the deeper takeaway. Quantum physics shows us that reality is not fixed. It's not as solid or predictable as it appears. At the smallest scale, everything is fluid, connected, uncertain, and influenced by observation. It challenges the way we think about existence, about control, about certainty. And maybe that's the point. Not just to understand the universe, but to realize how little we truly know. So next time you look around, at your room, your phone, your own hands, remember this: what you see is only part of the story. Beneath it all, there's a hidden world, a strange, beautiful, and deeply mysterious layer of reality, where particles are waves, where observation changes outcomes, where everything is connected. That world is quantum physics, and now you understand it, at least in the simplest way possible.
That was excellent. Please like and subscribe for daily lessons. See you next time.